Hello and welcome to PreCalc. Today is Tuesday, November 17th, and our topic for today is zeros of polynomials and a little review of point-slope form. Okay, great. Our guiding principle today is called the fundamental theorem of algebra. And it states that the degree, remember degree just means highest exponent in standard form. The degree of a polynomial is equal to its number of zeros. Okay, let's dive into our first set of examples here. First, we're just going to start by reviewing degree. Our highest exponent here is 4, therefore our degree is also 4. Remember to pause whenever you need and make sure that we're writing down these original problems. This has a degree of 5 because its highest exponent is 5. Okay, let's consider these three parabolas. Right off the bat, we know they are all degree 2. We know this because that is our parabola shape. Okay, now we're going to determine the number of real roots. A real root appears as an x-intercept on a graph. So we can just define it as x-intercept. Make sure that you've paused and done a sketch of these original graphs. Okay, on our first one here, we're going to have 2 real roots. This guy here is what we call a double root because it bounces off the x-axis. So we have one real root here, which is itself a double root. And we knew that because of the bounce off the x-axis. Our last guy here, we don't see any x-intercepts. So there are, in fact, 0 real roots. Whenever we see a parabola opening away from the x-axis, that indicates imaginary roots. So let's write that. We have, here's our x-axis, right? So this parabola is opening away from the x-axis. And every time we have a parabola opening away, that gives us 2 imaginary roots. Okay, let's consider another set of graphs. For each graph here, we are asking the question, how many roots does each graph have? Right. So our degree is given as 3 for each of these. So let's consider our first one. I see 1, 2, 3 intercepts. That's going to give us 3 real roots. On our second one, I see this x-intercept and this x-intercept. Remember, this guy here is a double root. The comes and it bounces and changes directions. So that's a double root. So our two x-intercepts indicate two real roots, one of which is a double root. Okay. The last one, I'm only seeing one real root here, but then we also have a parabola opening upwards and away from the x-axis. Parabola opening away from the x-axis gives us two imaginary roots. Okay, we are going to consider one more slightly complex example. Make sure that you've paused and written the original problem. Okay, it gives us our function. So off the bat, I see my degree is 6. Now let's count the number of real roots. I see 1, 2, 3, and 4. Okay, so that gives us 4 real roots. And then I have this little parabola here opening away from the x-axis gives us 2 imaginary roots. You'll notice that in this case, we do add up to the total degree, but the number does not necessarily always add up. Because we can have, for example, triple roots, because if we just look at the graph of x cubed, this is only one real root, but it is a triple root. So the number of real roots is not necessarily the same as the degree, and that's because we have double and triple roots. Okay, let's shift gears a little bit here, and we're going to do a review of point-slope forms. So let's remember that our point-slope form is y minus y1 equals m times x minus x1. And in this case, we also need to find our slope itself. Remember that our equation for slope is y2 minus y1 over x2 minus x1. All right, let's label first. Here I have x1 and y1 and x2 and y2. First thing we need to do is find our slope. We have y2 minus y1. We have 2 minus negative 1. Always move nice and slow here so you can catch things like these double negatives. And then in our denominator, we have negative 1 minus 1. Okay, we're going to get 2 plus 1 over negative 2. So our slope is negative 3 halves. All right, let's plug into our point slope form now. I have y minus 2 equals negative 3 halves times x minus 1. We made a little mistake up here. Maybe you caught it. I accidentally used y2. I should have used y1. So let's go back and fix that. We have y minus negative 1 equals our slope times x minus x1. And we'll just correct this to y plus 1. And then we can leave our final answer as point slope form. That's everything for today, guys. Thanks.